So let's rewind a bit. Before late 2022, the world of large language models had this fundamental split. You had AIs that could think, reason through a problem in their own digital mind. And you had AIs that could act, models that could actually execute commands. But getting one single model to do both of those things together and do them well, yeah, that was the holy grail.
Think about it like this. On one side, you had these brilliant thinkers, but they were essentially trapped in a box. They could have these complex internal thoughts, but they were totally cut off from the real world. And this led to that massive problem we all know too well now, hallucination, where they just confidently make stuff up. Then, on the other side, you had the doers. These were more like simple robot arms. They could follow a command perfectly, but they couldn't plan, they couldn't adapt, they couldn't handle anything new. The challenge was obvious. How do you connect that brilliant brain to a useful arm?
And to really get why this was such a big deal, we need to hop in a time machine and go back to early 2022. Because at that point, large language models were becoming unbelievably good at reasoning.
At the time, the big breakthrough was this incredible new technique called chain of thought prompting. It was almost deceptively simple. By just telling a model to think step by step, researchers suddenly unlocked this amazing ability for it to work through really tough logic puzzles and math problems. It was like we'd finally given the AI an inner monologue. But that inner voice had a massive, critical flaw.
And here's the problem, put perfectly by the very paper that would go on to solve it. This chain of thought process was a static black box. Because the model had no way to check its own work against reality, its reasoning could just spiral off into complete fiction. It couldn't do a quick search, it couldn't verify a fact it thought it knew, it was just guessing based on old training data. It was, for all intents and purposes, a brain in a vat.
And that brings us to the fall of 2022. And the publication of this incredibly elegant paper that proposed a simple yet powerful solution to finally get that brain out of the vat. The paper was called ReAct.
So what is ReAct? Well, the core idea, and it stands for reason and act, is to just stop treating thinking and doing as two separate things. Instead, the model generates both a thought, a little piece of reasoning, and an action, one right after the other, in this tight, continuous loop. The thought tells it what to do, and the result of what it does then informs the very next thought. It's a beautiful synergy.
So here's the magic, right? It all comes down to this super simple three-step loop. First, the thought. The model thinks to itself, okay, to answer this question, I need to figure out X. Then, step 2, the act. Based on that thought, it actually does something, like using a search tool to look up X. And finally, step 3, the observation. It gets the search results back. And that new information feeds directly into its next thought, letting it update its plan on the fly. Think, act, observe. And you just do it all over again.
All right, so that all sounds great on paper, right? But, the proof is in the pudding. Does it actually work? Well, the researchers put it to the ultimate test with a kind of problem that absolutely stumped the older models. They gave the models this exact question. Now, for you and me, we might be able to figure this out. But for an AI back in 2022, this is a really tricky multi-hop question. It can't be answered in one go. The AI first has to figure out what program the Apple remote was even designed for, and then it has to figure out what else can control that program.
And this, right here, this is where you see the night and day difference. On the left, the old chain of thought model just hallucinates. It makes a bad assumption that the remote was for the Apple TV, and then confidently gives a totally wrong answer. It had no way to check itself. But now look at the ReAct agent on the right. It's methodical. Thought 1, I need to search for Apple remote. Act 1, it does the search. Observation 1, it finds out it was designed for a program called Front Row. Aha, that new fact informs thought 2. Okay, now I need to search for Front Row. Act 2, it does another search, and the observation from that search gives it the correct answer, the keyboard function keys. It's just a brilliant demonstration of grounding your reasoning in reality.
And this wasn't just for answering trivia. The researchers decided to really push it by testing ReAct in something called Alphworld. It's this complex text-based world where an AI has to navigate a virtual house and complete multi-step tasks like go find the apple and put it in the fridge. I mean, it's a true test of real planning and decision-making. And, wouldn't you know it, ReAct just blew the older methods completely out of the water.
And the results, they were just staggering. On this complex ALF world task, ReAct got a 34% absolute improvement in its success rate over the previous state-of-the-art. That's not just a little better, that is a gigantic leap forward in creating AI agents that are actually capable and reliable.
So the takeaway here isn't just that they built a better model. What this paper really did was hand the entire field a new blueprint, a whole new way of thinking about how to build autonomous AI. And it's a blueprint that has basically defined everything that came after it.
And you can really see its impact when you just look at the timeline. Before 2022, we had these separate ideas. Then Chain of Thought came along. But ReAct shows up right here in October 2022, and it's like the starting gun for what we now call agentic AI. That simple, powerful thought-act-observation loop unlocked this absolute explosion of new frameworks. Seriously, almost every modern AI agent you hear about today, from Langchain agents to AutoGPT, uses some version of that core ReAct loop as its engine.
So, when you really boil it all down, the legacy of ReAct is that it taught an AI how to show its work, how to take its internal thoughts and turn them into concrete, verifiable actions in the world. It finally connected the brain to the hands. And that leaves us with this really fascinating question for the future. Now that reasoning and acting are working together, what's the next essential human ability that AI is going to model and master?
This is for entertainment purposes only.